This video is going to go over solving literal equations. This is after your first lesson quiz. And so basically the premise here is that we are using equations in a lot of different subjects. You might recognize some of these as geometry equations, but the one that you're really going to want to get good at solving equations for is when you'll take chemistry or integrated chemistry and physics next year, and there's a lot of equations that show up there. And so all we're doing is using our properties of algebra to go ahead and get variables by themselves. So instead of solving getting a number, we're going to get some letters. So I thought I'd start out with one that's a little bit different, so that you see that you can just use your regular geometry properties. So I have hot dog times hamburger plus birthday cake equals, I think that's watermelon. And so here's the steps, and these are the steps whether or not you're using food or variables. If I'm solving for hot dog, I'm going to circle it, and then I want to get it by itself. So I look over and what's keeping it. Well, I'm going to subtract, and I'm going to try to draw this birthday cake really fast. I'm going to subtract birthday cake from both sides. So over here I have watermelon minus, and I'm going to start making the birthday cake just like this weird shape. And here the birthday cake's subtracted and they're gone. So now I have hot dog and hamburger. So those two are being multiplied together. So to solve for hot dog, I'm going to divide by hamburger. And this is a terrible hamburger, I realize. But whatever I do to one side, I do to the other, keep the equation in balance. Those cancel out. So hot dog is equivalent to watermelon minus birthday cake divided by hamburger. Kind of funky. Let's go to the next one. I have another silly one here. So I have 3 bananas. You've seen one like this. We did it the first day. Plus 7 apples equals 3 slices of pizza, and I'm going to solve for apple. So I'm going to do first is, since I'm solving for 1 apple, I'm going to change this to put some symbols. So 3 bananas plus 7 apples equals 3 slices of pizza. Okay, so now I can follow my steps. I'm going to circle the term or highlight it that has the apples. I need to get that by itself. So to do that, I'm going to subtract 3 bananas from both sides. So I have 7 apples equals 3, that's a little crooked, 3 pizzas minus 3 bananas. And now I'm going to divide by 7. So I'm doing the same steps I've been doing in my algebra with numbers, only the numbers they're not like terms, so things don't cancel out and combine. So I'm rewriting my formula, whatever that was. So an apple is equivalent to 3 pieces of pizza minus 3 bananas divided by 7. Which is, I mean, it's just nonsense. But being silly. So we follow our same rules. I usually circle the variable, highlight it, get rid of fractions by multiplying, parentheses, isolate the variable. Basically the same steps you do to solve. Solve for the variable, though, you're going to have variables on both sides of your equation in your answer. Okay, so we're going to do a few of these. So these are on your notes paper that you picked up. So I just want to start out with some that are kind of simple. This is just a regular equation, so you wouldn't know any difference. But solve for A, your technique would be to circle the A and see what's keeping it from being by itself. So A equals 4. So same technique, we just don't usually circle that variable. You can if you want to think about it that way. 19 plus x equals negative 15. I got to subtract 19 from both sides. X equals negative 34. So those are solving for. The direction is the same, only we have all numbers. So if I go over here to this side and I'm going to solve, I need to solve for A over here. So I see the A, I'm not going to circle it because it'll mark it. I see the A right there. What is keeping A from being by itself? Well, it's being multiplied by 7 and C. So I'm going to do the opposite or inverse operation and divide by 7 and divide by C. So B over 7C. So some people struggle with it. That's your final answer, just right there. You don't need to have anything else. And so in science, you would do this, and then somebody would have told you what B and C are, and so you can plug them in and figure out what A is. Okay, so for 2B, I'm solving for X. So there's my X. It is being added to QT, so I'm going to subtract QT from both sides. That's gone. X equals 5 minus QT. And as long as X is isolated or by itself, you're done. I'm going to skip around here a little bit. So again, these over here are traditional solving, so I'm going to let you go ahead and solve those like you would. Here's one that's a little tricky. Solve for n. So there is my n. Well, the thing that we need to do is get rid of this fraction, because we can't do anything with the n until the fraction is gone. So the fraction means divide by 4. I'm going to multiply both sides by 4. So n minus x equals 4y. So now that I have a little more space, I'm going to keep this n highlighted. What is keeping the n from being by itself? There's an x being subtracted, so I'm going to add x. And there are not like terms here, so this doesn't become 4yx. They're not like terms, so we can't combine them. And in math, question 4b, this is the kind you're going to see more than anything, is solving for y, because we'll use that when we graph. So again, solve, isolate, get it by itself. What's keeping it from being by itself? There's a minus 10x. So I'm going to add 10x. Bring this down, I have 5y equals 10x plus 25. Now I can divide everything by 5 to isolate the y. 10/5 is 2 plus 5. And now y has been solved, it's isolated. You can always check at the end, is the thing that's by itself what you want to be by itself. We'll do one more. This equation over here is the equation from converting Fahrenheit to Celsius and Celsius to Fahrenheit. And so if we know Celsius, we can plug it in and find Fahrenheit. But in this case, it says solve for C, so we must know, or we must want to get it in another form, so we want the F on the other side. So I'm going to get C by itself. So what is happening here? It's being multiplied by 9/5 and being added to 32. So I'm going to subtract 32 right away. So I have F minus 32 equals 9/5 C. So right now it's being multiplied by 9/5, so I need to divide by 9/5, which is the same as multiplying by 5/9. So when I do that, I get C equals 5/9, and now I need to put this in parentheses, and I'm multiplying everything. And so actually, if you look up the formula for converting Fahrenheit to Celsius, you'll see both forms of this. Depends. If you have a whole bunch of Fahrenheit, you can easily plug it in. Think about it, it makes sense. 32 degrees Fahrenheit is equal to 0 degrees Celsius. So if you plug in 32, 32 minus 32 is 0, and it works out. 100 degrees Celsius is 212 degrees Fahrenheit. So you could actually plug that in, 212 here, and that would, if you took 100 here and put in 212 here, it would work. Okay, so that's your notes. You can go ahead and work on the rest of those problems. Remember, circle the variable, try to get it by itself.